Now it's time to talk about the unit operations, and unit operations are essentially all the blocks that are present right here. Some unit operations are very interesting, such as reactors, distillation columns, and others are very simple, such as simply being a mixer or a splitter, maybe a flash drum or a heat exchanger, and so on. Even between heat exchangers you can have a very complex heat exchange system right here, or a very simple one which will only model the heat amount or the heat duty required. So let me give you an overview right here. This is the mixers or splitters. Essentially they will either join or split streams. Material streams, you can also add heat streams, work streams, etc. Separators are essentially based on one single stage equilibrium base. So for instance, flash 2 will be used to separate vapor and liquids. A decanter will be used to separate the heavy liquid and light liquids, and so on. Exchangers will be used to heat or cool. This heat exchange will be a little bit more precise on the amount of streams requirements, the cold and hot streams, and so on. We have columns. This is a distillation column unit, and this is a simple distillation. This is much more, let's say, complex, and this, let's say, more detailed distillation model. You have extraction, multifraction, and you can also model absorption units, and so on. Typically, we will be using these as distillation columns or absorbers. We have the reactors. They will be based depending on, for instance, this one right here will be for stoichiometric reactions. This will be based on a certain yield, and these two right here are based on equilibrium reactions. This will calculate the Gibbs free energy. They will use the K value in order to see which reaction is favored, and the activity fugacity calculated in order to achieve equilibrium. Or we have this, the CSTR, which is the continuous stirred tank reactor, or the plug flow reactor. Even batch reactors we have. Pressure changers are relatively simpler than the columns and reactors. They are pump, compressors, a multi-stage compression, a valve, and pipes if you want to model some pressure drops. Manipulators, we're not going to use these ones right here, but they're also very interesting, especially when you are working with a complex system. Solids, well, we are not going to use solids, but you can use solid separation, solid manipulations, crystallizers, and so on. Or if you have a model, you can use it by yourself. You just need to input the data, and let's say you have this model which is a very unique model for membranes. You just add it, and that will be. So whenever you have doubt, simply go here. Since we are in this simulation environment, open the simulation environment and unit operation models, and each unit operation model is explained. Let's say we want to understand the R-star, the reactor stoichiometrically based, and as it says, the reaction kinetics are unknown or unimportant. For instance, in combustion, we don't care how it goes because we know it's fast. We just want the outcome, which will be temperature and the mass balance. The stoichiometry is unknown, or you can add it, and you can simply specify the extent of reaction or conversion. So this is one of the simple one. The yield is typically based on reactor stoichiometry, still without kinetics being the important factor. You just add a yield distribution data, and the reactor will calculate all the pertinent data. So this is the most important part of the unit operations, just to know where they are placed, and in the following videos we will be working with the plant and adding all the input requirements for each unit operation used.